Yes, it is visible.
Yeah. So let's switch to C drive, Streamlit folder, and here uh, this is the file. We started working on this file on December 9th. That's on Monday. So I'll just let it occupy the window on the right side. Okay. Right. So we created home page, then we created a dashboard page, and today we are going to create AIML page, AIML page. So first thing what I do is I will run this code. So I'll change to the directory where the code resides. So and run this command. Uh, this command. Right. So obviously to load it for the first time, it will take a moment. So then we can start seeing. Right. So this is the home page, the default page, home page. It will always load the first page. Yesterday we created this dashboard page. As we select the data, the page will extend. Okay, which is pretty interesting. Now today we want to have another item in this list box, select box. Okay, so that's going to be AIML models. AIML models. Okay, so let me add that AIML models. Okay, this is another page we want to add. So now to the select box and in the sidebar, so to the select box, okay, there is a second parameter. In the second parameter, we add this additional item. So that is AIML models. Okay, so this is the additional item we add. So let's refresh the page. I save the page. So the moment I save the page, I'll be prompted to rerun, always rerun. So when we choose that, it will always rerun. Now we can see AIML models. Okay, right. Now we are going to use something related to AIML. So, and this page, when somebody chooses AIML models, this page allows users to interact with the predefined machine learning models like regression, classification, and clustering. Okay, regression, classification, and clustering. So, else if page value is AIML models, this is the item if they choose from the drop down. So AIML model, and then it should run a code, so a function called AIML models. AIML models. Right. This is the function it should run. So when you choose that page, of course there is nothing inside this page. So I just type pass. That's it. Okay. So right. So elif statement is not complete. So AIML models. That function is called AML models. Okay, now we don't see any error. Now we are going to replace this. Okay, but for AIML, you need a lot of machine learning libraries. The first one is library used for data science and machine learning. The second one is also used for that purpose. Third one is also used for that purpose. In fact, all the libraries except the data and time, module, and this is the data and time constructor from module. Except for this, all the libraries, above libraries are machine learning libraries, are data science libraries. So additionally, I would like to import some libraries from sklearn. This is a machine learning library. Okay, and this library, from this library, we are importing the module called model selection. Okay, so this model selection will help us to select the model. What model you want to run? Do you want to run a regression model, or you can specify the model that you want to run? So from this model selection module, okay, we are going to import uh, a function. Okay, train, test, split. And you may ask me, what does it mean? Okay, I'll just give you a simple example. So you have 100 rows of data, 100 rows of data, and you will use that 100 rows of data to teach your algorithm about that data. Okay, it will read that 100 rows of data, and from that 100 rows, it will learn the connections and relationships within the data, and it will learn some patterns from the data. Using those patterns, whenever a new data comes, it will make decisions or it will make predictions based on the data. Okay, so but normally when you get 100 rows, this is the common practice that you split the 100 rows into two parts: training data and testing data. First 80 rows or 70 rows, you train the algorithm on the data for using the 70 rows or 80 rows, and remaining 20 rows we use it for testing. So we split the data into two parts. Okay, 80% of the data at most for training the algorithm, and remaining at least 20% of the data for testing the algorithm, how well that data is trained. Okay, I'm not going to get into all those nitty-gritty details. And also, we want to use algorithms like linear regression. Okay, so from uh, sklearn, again, this is a machine learning library, sklearn. So linear model. So we want to import the linear model. From that, we want to import an algorithm called the algorithm model called linear regression. So this is the first algorithm people learn uh, in their machine learning journey. Okay. Then after that, this is used for predicting. Okay, predicting a numeric value. Linear regression. It is a statistical concept. If you are from statistical background, you understand this. Any data scientist, data analyst, or machine learning person or AI person needs to learn these statistical concepts. Otherwise, they cannot make predictions. Okay, linear regression is for predicting a numeric value. Then we'll also use another algorithm. So other than linear regression, that is logistic regression. Okay, so this is also a prediction algorithm, but difference is the linear regression will predict a numeric target. Okay, numeric target, like given three inputs, the area of a house, and number of rooms in the house, and the age of the building. So you can predict the amount. Okay, so that amount will change based on the area of the building, and the number of rooms and the age of the building. Okay, that's number one. Okay, but on the other hand, we have logistic regression. Okay, logistic regression. So logistic regression is all about uh, you know categories. Okay, so you can say whether a email is a spam or non-spam, or you can say whether a person is going to win this match or going to lose this match. So you can categorically find the make the predictions. Okay, this is another regression algorithm. I'm only concerned about typing properly, so because we make spelling mistakes. And we also have another algorithm from this, not just linear model algorithm. Okay, another algorithm that is called cluster. There is a model called cluster. From this we use k-means algorithm. So this k-means algorithm will find a particular object, does it belong to category 1 or category 2 or category 3? Okay, that's what exactly it does. Okay, and after that we use some metrics. So from the same machine learning sklearn algorithm, okay, we have a module called metrics. From this we import mean squared error. So as this error comes closer to 0, so your prediction is more accurate. Okay, some of the mean squared values. Okay, so right then accuracy, this is another metric. So we use this metrics and we'll find out how well we are able to predict or classify. So then we have matplotlib, so which is a usual machine learning library. Okay, so matplotlib pyplot, okay, which is for graphing. Then we have that. Then we have this. Okay, right. So now I'm going to write the function. Okay, so of course this program may appear very cluttered, but everything that is under home function, that belongs to home page, and everything that is under let me scroll down, data dashboard belongs to data dashboard page. Now can I separate them into multiple files? Yes, you can separate them into multiple files, because in Python you can write modular programs. That's how we do it actually, because I just want to show you everything in one single page, so we are just following this. But otherwise I personally prefer to use multiple pages. Okay, but however it is very simplistic compared to using HTML, CSS, JavaScript. Okay, in fact I always suggest students to learn those things, but at the same time don't learn them to the extent where you will not use Python. Okay, always keep that in mind. So we teach Django for application development, and we also teach DevOps for continuous integration and continuous deployment. So I choose AI models, AI/ML models, AI/ML models. So let me save this. uh, it should load the page. AI/ML models, AI/ML models. The page is equal to AI/ML. I think this is models. Yeah, the plurality is missing. Yeah, right. AI/ML models. This is the title we have, and then so after that, so what we'll do is we'll write some text. So we'll put some text, and I'm going to use short heading. So welcome to the AI and ML models page. Okay, so choose a model, uh, type to export and interact with. I think yeah, I'll write it everything on this single line, and we can make changes to it later. Or else I do one thing. I'll make it a simple write-up. Instead of using hashes, I'll use three codes. So this will make it a multi-line string. Okay. So welcome to the AI/ML page, and in the next line, okay, we write welcome to AI/ML page, and choose a model type to export and interact with machine learning algorithms. Machine learning algorithms. Okay, right, and upload your data set or use a sample data set. Use a sample data set. Now we are done with this. So let me save this. You can see a small write up for that. Okay. Now let's create uh, a small select box, okay, which is nothing but a drop down. From the drop down, a person will choose the type of machine learning algorithm they want to learn. Is it a regression, classification, or clustering? Regression, classification, or clustering. If you go up, we have we did import, okay, regression algorithm, that is linear regression, classification algorithm, that is logistic regression, and clustering algorithm, that is k-mean. Okay, k-means. Okay, we have all these algorithms. So which algorithm you want to use on your data? Okay, first thing is we should know what is our objective. After we know that objective, we can choose which algorithm we want to use. Okay, so now, but for our purpose, let's create a small drop down, model selection. Okay, model selection. So I use select box, and from this select box you will see a label for this. Choose the type of model. Okay, the type of model, right? And I'll give a list to choose the model types. Options equal to, this is the list. Regression and classification, and finally clustering. So clustering, right? So a person may choose one of these three algorithms. One of these three algorithms. Okay, right. Now they may choose one of these three algorithms. So regression, classification, or clustering. But however, when they choose this algorithm, we have to store that choice in a variable. So let's call that variable as model type. The type of the model they choose. Either uh, they choose one of the three models, that is regression or classification or clustering. Okay, regression, classification, or clustering. They choose one of the three models. Okay, right. Now, after that, we select and upload the data. So we need to select a data set we need to upload. Okay, or we need to select the data. So we have a lot of popular data files. Okay, I'm going to load one data file from internet. I think it is available on my PC. If it is not available, we can download it. So let's check whether it is available on my PC or not. So there is a data set named Iris. Uh, Iris data set. I don't think it is there. Okay, for some reason it is not there. So Iris data set. Let's download it from internet. So I'll just go to Google, and from the internet I'll download it. Iris dataset. Iris dataset. So in the form of CSV. Okay, so you can see Iris on the Kaggle. Immediately people will go to Kaggle. So we are going to download this. So Kaggle. So this is the file. Download the dataset. I need to sign up. Sign in. I already have an account. I need to sign in. Okay, let's download. Download the dataset. We have downloaded it, the dataset from Google. So right. So here, this is the file. I just copy this and I'll store it in the folder, my intended folder. Okay, my intended folder. Right. So this is the file. I just open this file. I open this file. Let the file open. Yeah. So you can see this is a data set with 6 columns. Okay, this is ID. ID is always a sequence of numbers. Okay, then you have this is a a flower plant species. Okay, so there are three types of for plant data here. One is setosa, iris setosa, iris versicolor, iris virginica. Okay, so these are the three plants, and by looking at the sepal, every plant has sepal length, sepal width, petal length, and petal width. Every flower, okay, has sepal, petal. Every petal has its width and length, and every sepal has its width and length. So using this, our species can be predicted. But before that, these four parameters, we need to feed this data. So it will learn from this data. And whenever you give new data, when you give sepal length, sepal width, petal width, it will predict the class. Okay, right. So this is very, very important data. Okay, it is a CSV file. So I'll close this data. So it clearly says this is a CSV file. Okay, I don't need to save it, but it is in the same directory where our code file resides. Okay, now we have to upload that data. Okay, let's upload the data. So now what I do is data set upload, or you can say sample data set. Either you can upload the data set or you can put the sample data set. Okay, so what we do now is we are going to write some text. So we are going to use third level header, okay, using 3 hashes. So upload your data set or use a sample. Okay, either upload it or use a sample. So let's use a function from Streamlit, that is file uploader. This is the function, and this will give us an interface to upload the file. So we'll simply put upload a CSV file. That is a label that we want to use for this particular function. That's a label that we want to display on the page. Okay, then the type of files it will accept, the type of file it will accept are, okay, so only one type of file we want to accept, so that is CSV files, CSV. Okay, comma separated value files. Okay, right. So obviously when you upload a file, it will create a file object. Let's assign the file object to this variable, uploaded file variable. Okay, because that's how we can work with the file. If you don't assign it to a variable, you cannot work with the file. So if the file is uploaded, so let me save up to here. So you can see upload your data set or sample data. So that is the heading you see. After that, you see upload a CSV file. So this is the you know option, or this is the object that you see. You can browse for the file. Okay, you can browse for the file. We are going to use this iris folder. Okay, right. But for now, keep in mind that is exactly we are dealing with. Okay, right. Now if the file is uploaded, if uploaded is true, okay, if uploaded file variable, if it is true, okay, the file is uploaded, okay, if that is true, then we take the pandas library to read that file, the pandas library. So this is the library, we use this library to read that file. So let's do that. Okay, so now this is AIML model. So we have this. So we are going to use from pandas, we are going to use a function called read CSV. It will help us to read CSV files, and in this case it is uploaded file. It is an uploaded file. It will read the uploaded file and it will create a data frame. So assign the data frame to a variable called data. Okay, right. So if the file is successfully uploaded, okay, then you have to print success. So success will print something in green color. Okay, once the file is uploaded, we can print something in the green color. So file uploaded successfully. successfully. This is what you do. Okay, right. That's first thing. But if it is not that case, so if the file is not uploaded, so else, if the file is not uploaded, else, okay, else, so we will just give some info. Okay, like using the sample data set, we'll use some sample data set. Okay, right. So the fortunately, uh, we have already downloaded the iris file, but even if the iris file is not there, we can get it from internet. So and we can just put some information. This will appear in blue color. Okay, using sample data set, using sample data set, it will put some information. Okay, right. Let me save up to here. Okay, right. So we have saved up to here. So you can use sample data set also. Right. Now after that, okay, so in this under sample data set, uh, we have already imported a library called SNS, which is Seaborn library. This library comes with some data sets. Okay, one of the data set is IRIS, the same data set, that we downloaded it. But if for some reason if you couldn't download it, you can also access it from here. So SNS has a function called load dataset. This function, using this function, and you can specify the dataset name. So there are several dataset names. For example, if you go to Google and type sns.dataset, so it can load a lot of types of datasets. So you can see uh, there is anagrams dataset. Okay, there is some data attention data set. You can see this data set, attention data set. Okay, it talks about, I think, attention span of students could be, or subject. In this case, subject means student. So is it divided attention or undivided attention, or focused, divided or focused? So you have different these things. Okay, so there are a lot of data sets available, built-in data sets are available, and it's very famous actually. Okay, but let me not talk about it a lot. So after this, uh, we load this data set and we assign it to a variable called data. Right, you can do either of this. Okay, right. So that's another thing. So now you will use this iris dataset. Okay, if the iris dataset is available, if model type is regression model. So we have three model types. So we wanted to use three model types. So what are those three model types? Regression, classification, and clustering. Okay, so these are the three model types we want to use. So you can see in this variable, the model type that you select will be stored in this variable. So if the model type is regression, okay, choose iris dataset, because iris dataset is only for um, regression or logistic regression. So if the model type, okay, is not equal to um, regression, okay, so regression, if the model type selected is not regression, it can be classification, or uh, it can be classification, or it can be clustering. Okay, but it's not equal to regression. Else use data frame. So data frame is a function from pandas. So I told you in the beginning, we use the word data frame to refer to uh, what do I call, to refer to uh, um, two-dimensional data. Okay, so in this data frame we are going to create a dictionary, Python dictionary. X1 is the column name. In this column we'll generate numbers from NumPy, use random module, and from that use rand function and generate 100 values, 100 random values. So this is for first column. Similarly, for second column let's call it as x2. So x2, even for this column, use numpy. Random module, from the random module, use rand function. It will, and you want to generate 100 rand values. Okay, then y. Okay, so x1, x2 variables are independent variables, and those two are inputs, and based on those two, you get y. Okay, so numpy, random module, rand function, and we generate 100 values. But for y, we multiply each value with 100. Okay, we are done with the dictionary. We are done with this. You know, um, a data frame function, right? We have created the data. Okay, so beautifully we have created the data. So after creating the data, so after that, so the point is very simple. Either you upload the file. If you are not able to upload the file, and if you don't choose regression algorithm, take iris data from this library, or else you generate your own data. You generate your data. If it is regression, generate three columns: x1, x2, and y. Okay, these are the columns. Okay, right. Now that's number one. Okay, right. Now we are going to write the data now. Okay, we are going to write something to the screen. Okay, so as of now we don't have anything, but we are going to write something to the screen. So that is dataset preview. So whatever dataset you choose, it should be viewed. Okay, so preview. So, and how do we preview it? Use the data frame function to display the dataset. So whatever data you select, whether uploaded from the file or whether you get it from other sources. Okay, so data uh, should be displayed only first five rows. Only first five rows of the data should be displayed. So right now you see, we don't select the regression, we select the classification, and the moment we select classification, so it takes the since we didn't upload any file here, the file is not uploaded. This is false, so it will go here, and because we chose classification, it shows the iris data. Iris data. No, this is the iris data. Okay, iris data. Right. Okay, for clustering also, it shows the iris data. Iris data. So it shows the iris data. Okay, right. But if you select regression, it will take that data that we created. With x1, x2, x3, x1, x2, and y. Okay, with these three columns, it will generate the data set. So we can generate data like this. Okay, very, very simple. Okay, right. And we are just displaying the first five rows. But if you want to display first 20 rows also, you can display first 20 rows. See, the data is displayed first 20 rows. Okay. If you select classification, it will show the classification related data, which is iris data. If you show the clustering, it will show the clustering data, which is also same data. And even if you select from drop down here, so you can also select. Yeah. So same data, we are selecting the same data. So we are just displaying the 20 rows here, first 20 rows. So if you think first 20 rows is very big, just set first 10 rows. If you don't give any number, it will select the first 5 rows. Okay. Right, we have displayed the data so far. Now we are going to select the model. So there are three models, machine learning models: regression, classification, and clustering. Those are the three models we have. Okay, right. So from these three models, we will select the model type. So model specific logic we need to apply. Specific logic. So the if model type, model type, if it is equal to, so there are three models you can choose: regression, classification, and clustering. So if the model type equal to regression, okay, if that is regression, if the model type is regression, okay, and if that is true, then we'll write uh, linear regression. linear regression. Okay, right. And if it is linear regression, so when you select regression, it shows this data. Okay, so when you don't upload any file, when you select regression, it shows x1, x2, y. It shows this data, x1, x2, y. Okay, right. So let's, if you select linear regression, then you have to write another if statement inside this. Okay, if y not in data columns, if the y is not in data columns, of course y is there in data columns. Okay, data object and columns, but it is there. If y is there in the data columns, so then it is error, because not just input x1, x2, you should also have output. So these two variables are used to predict y. X1 and x2 together used to predict the y. So that is an error. So your data set must have a target column named y. Okay, named y for regression. It needs to have a named y. Okay, and also uh, then there is no point of running this uh, analysis. So we return it. Return means it will end the function. It will end the function. This function ends return. So that's what exactly we do. Okay, return it. And otherwise, okay, if the model is not regression, if the model is regression, and that's number one, and there is a data column. Okay, so model is regression and there is a data column, then what we are going to do is we'll do data splitting. So we split this data into two parts. One few rows for training the algorithm, few rows for testing the algorithm. This is all data science, and some of you may not be aware of it, but don't worry. So you will understand it going forward. So x equal to data dot drop any data. We take columns. Okay, y. So I'll explain this in a moment. Okay, x is equal to data dot drop, and y lowercase y equal to data y column. Okay, so x means x1 x2 columns. Drop the y column. You have x1 x2 column which are inputs for your prediction, and y means output. So just take y column from the data. Okay, right. Then what we do is we take the rows, we split them into two parts, x train and x test. So we take this x1 x2 columns and we divide them into training data, testing data, and equally we split them into uh, y training and y testing. Okay, so y train, y test equal to, so we use train test. This is the function we imported in the beginning. Split. Okay, so x and y, take these two inputs, and test size is 0.2, 20% data for testing, and fix it. So to fix it, we use random state is equal to 42. This is the value we use it. So it creates. Okay, since we chose linear regression, it shows linear regression. Of course, you don't see anything significant as of now. So we'll train the model. So we train the model. So we have split the data. Now we train the model. Model training. Model means here formula. You train the formula, and formula will adjust the weights. Okay, adjust the weights. So we are going to use the linear regression since we chose regression here. So we have a function here for regression, that is the function that we have imported is linear regression. Okay, so we are going to use that. We are going to use that. Right. So let's take that. So model training, and we are going to use linear regression model. Okay, so we'll assign it to a variable called model that we want to use is linear regression. Okay, and our data is split into 80% training for x1 x2, and for y 80% training, and testing 20% for x1 x2, and for y testing is 20%. So now you are going to use the data, how training data, the x1 x2 for training, how it matches with y training data. Okay, so similarly, you want to know the prediction based on the test data. So take the test data. Okay, so model predict. Okay, you take the test data and do the prediction. Okay, so which is simply prediction. Okay, prediction, and your your prediction should be same or almost close. That's the main idea. Okay, right. So now after this, okay, so I save it because I just want to see if there are any errors. So no errors so far. It's going perfectly. Now you have trained the model and we want to print the results. So we want to print the results. Okay, we just write something to the screen, that is uh, mean squared error. So mean squared error means, mean squared error. So the point is very simple. When we say mean squared error, we are actually saying that uh, errors are less. We need to have less error. Mean squared error value should become as closer to as possible. So that is a metrics to test whether our test data and predicted data uh, are same. Okay, so this is the mean squared error function which we are going to use now. Mean squared error. So let's do that. So that is a function we are going to use now. So right, mean squared error. So this is mean squared error and y test. So your testing data and your predicted data both should be very close. So at least up to we want to check up to 2 decimal points. Okay, right. I hope you know all these f-string formattings. You have learned all these f-string formattings in your class. So mean square error is 105061. That's a huge number, but don't worry. Okay, we are not looking for results here. We are looking for application development. So right, uh, you know, we are going to have a chart scatter plot of predictions. We'll have a chart for predictions, and we are going to use scatter chart. So, and we want to see the difference between y test and y prediction. So how the test and prediction values are close, and we want to use x label as actual, x-axis label as actual values. Okay, and y-axis label at predicted values. So y label, so predicted, y label predicted. Okay, right, predicted. And also we'll have a title for the chart. Okay, the plot. So it is actual versus predicted, actual versus predicted, and finally we will display the chart. Okay, that's what we do. So the extra L should be removed. So you can see scatter plot chart. So you can see how the values are predicted and actual values. So this is the predicted value, but this is the actual value. Predicted value, actual value. So predicted and actual almost close here. This is the predicted value, but this is the actual value, but this is the predicted value. Okay, so actual value and the predicted value. So that's how, if you look at this area, so these values are closer to actual and predicted. Okay, so there are some values which are closer to actual and predicted. Okay, right. So we have used one model so far. Now the question is, what if the model is different? What if the model is different? So instead of this regression model, what if it is a classification model? Can we write something for it? Yes, why not? So else if model type equal to classification. So you can have classification, okay, classification, if that is there. So just write, okay, logistic regression. So classification is the objective of logistic regression. Okay, and right. So here we write it, and then we are going to look at a lot of other things. So elif, we're going to look into a lot of other things. But before that, I just want to ask you how far you are able to follow. So especially, uh, everyone, not especially anyone, but everyone. The main objective you need to understand is, okay, stay till the end of the class. I'll tell you something. Okay, so just stay till the end of the class. There is something to discuss, so that you can benefit out of this session. Okay, right. So I want to simplify certain things for you. So just keep that in mind. So stay till the end of the classes. Okay, right. So in the classification, your data should contain more than two rows, at least two rows. Okay, so if length of the data columns, okay, at least two columns you have, more than at least two columns you have. If you have less than two columns, then you print error. So your data set must have at least two columns for classification. That is for classification. Okay, then data. So if there are no two columns, so there is no point of running this function. Okay, right. So the one column should be input column, other column should be target column. So in a machine learning algorithm, that's what we do. So target column selection. So how do you select the target column? Okay. So if you take iris data, the thing is different. Okay. If you take other data, the thing is different. Okay. So I'll do one thing. I'll write only up to here, and um, we will. I will just write this algorithm, steps for this algorithm. We are not going to write the steps for other algorithm. Okay. So right. So we are going to display a select box, and from the select box we need to select the column of the data, that is select the target target column. Okay, that is a target column, data dot columns, and we'll assign it to a variable called uh, target column. Okay, now let's see. uh, it's select box, and I think I need to save it again. Right, select box. Yeah, I didn't put any columns here. Yeah, I have the columns. I did put columns here, so there is no problem in the code. But still it doesn't display. Yeah, we didn't choose classification. If we choose classification, we'll see that. right? So you can see which is your target column. Species is the target column. Okay, species. So every flower is a species. Every flower type is a species. Okay. So if you look at the previous data, so we have species is the target that we want to find based on these four inputs: sepal length, sepal width, petal length, and petal width. Okay, based on these four inputs, you need to find this output. Okay, right. So the species is the target. So we have to select the species from here, species column. So that's the main idea. Okay, right. Now we select that target column. Okay, then from the target column, so the first four columns, 1, 2, 3, 4, or you can say excluding the first column, the four columns. But the data may contain just it may not contain this column. The first four columns may be iris input columns, and based on that input we'll predict the species. Okay, so that's what happens. So we'll take x. These are inputs: sepal length, sepal width, petal length, petal width, first four columns. Okay, so data drop. Okay, whatever you select in the target column, that column will be dropped from inputs. Okay, columns is equal to drop the target column. So the column that you select in the drop down, that will be dropped, and those values will become inputs. Okay, and the data target column will be the output y value. Target column will be the output y value. Okay, so we are just doing some machine learning thing here, and if you want more details, we will be conducting a thorough program on machine learning. Okay, target column. Okay, categorical if categorical. So right, if y data type is equal to object means text. If this text column, so is it text column? Why? Yes, it is a text column. You can see, not a numeric column like all the 5 columns you have. This is a text column. Okay, so if it is an object, okay, then y is equal to, okay, we are going to use factorize. Okay, factorize y, and we are going to factorize it. So in other words, we are going to just if you want to see what is factorized data, so I'll just use that data frame y, so you can see it. Right, data frame y. Factorize, yeah. So I think there is some error. No, this far there is no error. D type, there is problem here. D type. Oh, it is double equal to sign, not single equal to sign. It's double equal to sign. Right. That's the problem. Yeah. Data frame. So y. So it will save this, and you can see this is factorized data. Okay, let's see this data very clearly. More clearly. So this factorized data. This factorized data. So it factorized the data. So there are three types of plants, right? So if you look at the data, so Setosa, versicolor, and then we have Virginica. So it factorized the data. Setosa is now zeros. It is identified by zeros. Versicolor is identified by ones, and Virginica is identified by twos. So this is called factorization. Okay, factorizing the data. Okay, we have factorized the data, and we split the data into parts like training data, testing data. We'll split the data into parts. Okay, so splitting data splitting. Okay, right. So X train and X test. Okay, Y train. And if you think, all these things, what do they mean? We are going to have a machine learning sessions. So from there, you are going to learn train, uh, uh, test, split function. That's what we take. And also, our test size is 0.2 percentage, 10%, 20 percentage, and random state. We want to keep the data constant throughout the code, throughout the program. So we use random state 42. Okay. And finally, we'll do model training, and we'll do that model training. So let's model training. That means you train the formula using the data. Okay. So we are going to use logistic regression, which is actually classification program, classification, which is for predictions. So max iterations is equal to 20, or let's take 200. 20 is very small. So let's assign it to a model variable. Model. Okay, we are going to use this model variable, and we'll fit the data to the model. X train data, the data that we want to train the algorithm, and the outputs of that. And then we'll take the prediction. So whatever prediction we get, the prediction is model. So predict, sorry, no, model predict, and it is x test. Okay, take the test data and predict it. Okay, so right. So we are simply using machine learning algorithms. Okay. Now finally we'll bring the results. Okay. So we are going to write something to the screen. Okay. So accuracy score. And those who really want to, master all these things step by step, we have another, you know, workshop coming up. So there I'll explain the machine learning from scratch, where we don't assume any background for your machine learning, uh, you know, background, and that's where you will learn all these things from scratch. Okay, there is upcoming session. Okay, and finally, uh, we are going to write confusion matrix, and I will write it later, but I'll let me write it once for all. So we'll have a confusion matrix. Okay, it will not confuse you, but it will help you to understand how far your predictions are, you know, correct. Confusion matrix. Confusion matrix. Okay. So CM equal to PD cross tab. So cross tab means a table. Okay. Your test values and your prediction values. And with row names as actual, and with column names as predicted. So column names as predicted. Column names as predicted. Okay. And finally, we'll use a heat map chart. Yesterday we saw heat map chart. Okay. Your um, conversion matrix will be displayed that there. Okay. And we'll use an annotation which is true, and color map. Color is cool, warm color. You can try different colors. This is not a big thing. Format is integer format. Okay, right. And finally, we use pyplot and plt. Okay, let's see the outcome of it. Okay, so ypred reference before this. Where is that error? Line number 218 and 242. So 218. This is 218. It is used. Yeah, this is the spelling mistake. This should solve the problem. Pyplot has no attribute pyplot. Okay, it is pyplot, not pyplot. It is pyplot. Right. So you can see how well the actual values and predicted values. Okay, I will explain all these charts in different models. So as of now, I will just use only two models. One is regression. So this is the chart that appears for regression, and we have another chart for classification, another data for classification. So right, so here it is sepal length. So instead of that, select species. You can see the confusion matrix and you can see all the outputs. So this is one page, AI models page. So the first page that we created is home page. Okay, so and the second page that we created is dashboard, data dashboard page. So here you can browse the data file and you can create a dashboard for that file. Okay, for example, sales file. So you can start creating dashboard. You can have any chart type. I just used this, and heat map, and also scatter chart, scatter plot. And finally we have another page. It is a machine learning page. Okay, right. I know these things are very 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 difficult to comprehend as of now. I know that, being a trainer, I know that that's common, but don't worry.